Good afternoon, ladies and gentlemen. Welcome to Techgig webinar series. Topic for today's session is building or porting Android NDK apps for Intel architecture. And we have with us today Nalina Jain. Nalina is an application engineer at Intel who acts as a product evangelist and a marketer. Application engineers act as consultants and provide support to third-party product developers. Contribute to Intel software and hardware product development by providing tech feedback to Intel product teams. We also have Surabha Mysore, who is a Senior Program Manager, Android Enablement, Intel APAC, and she will be taking in questions today at the end of the presentation. We will have Nalina giving the presentation for the first 45 odd minutes, and we'll then open up the session for questions during the last 15 minutes. Nalina, I hand over the session now to you.
Thank you. Hi. So I hope everybody can see the screen, the presentation which I'm sharing across. Okay. So today I'll be talking about building and porting Android NDK applications on Intel architecture. So the agenda looks like this. So let's have a briefing on what is NDK and why it is used and what are its advantages over Dalvik applications. Then I'll get into developing an application which using the NDK. Then how do we port this NDK application onto x86 platform? Then we'll talk a few optimization steps, and there are few demos which will actually show you the migration of NDK apps on x86, and also there is an application which will show you the performance of Dalvik versus NDK. So this is a session which talks about Android native development kit. What is NDK? Heard a lot of when it comes for Android. You have heard a lot NDK. What is NDK? So it's a set of tools, or you can call it as a toolkit in order to incorporate native code. So when I tell native code, it is C and C++ code in order to port it onto in order to convert it into Android application. So as soon as I tell C and C++, people are very excited because we are very comfortable in C and C++. So Android has made us, I can tell there is a channel in Android SDK where actually you can port your native code using JNI, that is Java Native Interface. This interface helps you in porting your native code into the application. So why should we go for NDK? So are we not comfortable with Dalvik? So it's not about the Dalvik or NDK, it's about the performance. Everything in Android, when you talk about Android application, it's about performance. Mainly the performance of applications really plays a very important role in NDK. So what kind of applications are we targeting for performance? So it's mostly the intensive tasks, like let it be a complex algorithm, multimedia applications like a hardware decoder, encoder, and the gaming applications. All these apps require a lot of performance. So in order to boost this performance, NDK plays an important role. That is because of the native code. So why is the native code so flexible? That's mostly because C and C++ are the most portable languages. And when you are already having a C and C++ code, and somebody tells you can reuse that code in porting to Android application, who is not happy? That's where actually the NDK plays an important role. Software code reuse. This is actually one of the greatest advantage of NDK applications. And then the fluid and lag animations. What do you mean by the fluid and lag-free animations? So here it's about the compute-intensive applications like as I mentioned already, the hardware encoding, decoding. Here, when you want to push some of your offload some of your modules of the application onto graphics, that is GPU, native code plays an important role. So if you want to get lag-free animations, go for NDK. This is the differentiation which I'm talking about, the hardware access which is possible using native code. as it directly mentions, it's a direct advantage of NDK. So if you're not using it, what are you losing? You're not losing anything. The only thing is you're giving a better performance. That's the contrary to the complexity which it's going to add on to. This is about NDK, and a little bit of NDK history if I have to speak. This actually evolved a lot from Android 1.5, that is from the cupcake onwards, and it's now better from almost the Android 2.3 version, that is from the gingerbread onwards. There's a lot of improvement on NDK. Android Forum is actually giving a lot of importance to NDK. So Android 2.3, where actually the NDK was very well improved, that's when actually even the first version of x86 support came up on Android. So this is about the Android NDK introduction. Now let's get into a little more depth. What is NDK versus Dalvik applications? What is the role of Intel platform support on that? So you have a Dalvik app and you want to run it on the x86 platform. It seamlessly runs on x86 platform. There is no issues in porting the Dalvik application onto Intel platform. You want to port NDK applications onto Intel platform. Most of the applications run seamlessly without any recompilation or any kind of optimization required. And there are a lot of tool chains available from the Android NDK itself, which supports for you to port your application port your NDK application onto x86 since 2011. And some may require a small recompilation, which will yield you actually best performance. It's not actually for porting your application to NDK. It's more of yielding better performance on x86. That may require a simple recompilation. And if there is any specific processor code dependent, for example, which is actually hard coded for any non-Intel platform, there might be a porting necessary where actually you have to convert those into x86 compatibility. And also, when I'm talking about NDK versus Dalvik, I have to mention here, like more than, when you see the Google Store, more than 50% of the applications are NDK. So we better go to NDK. So I would like to share one of the case study which we have took it up when it was actually porting Android, that is the NDK application onto x86. It was a major game engine which we actually ported from Dalvik to NDK. It was majorly from, there was an existing NDK for a non-Intel platform. How did we port it onto x86? So what I have some few, like 3 or 4 problems which we face on porting versus how we actually ported onto the x86. So some of the problems, as I already mentioned, were there were hard-coded statements or instructions in the non-Intel platform tools which the NDK application used. So how did we overcome this problem? We had to rework on the scripts to include the x86 support. So that was actually how we overcome this problem of hard coding for non-Intel platform. So, and there was also non-Intel platform code for skimming. So this is actually, I would call it as it was a major problem. So how did we overcome this? Using the solution of the existing SSE code. So that's actually the streaming SIM instruction set which is already present for x86. That's already there for PCs, and now it's also available on the tablet processors also, that is the Atom processors, which is from the upcoming is the Betrel platform. So on that we have the SSE 4.2 instruction sets available for you for optimization on the tablet. And the next one was the pre-built libraries for non-Intel platform. So there were this game engine had lots of pre-bundled libraries which were specific for that non-Intel platform. So how did we overcome this problem? So as I already mentioned, when it is already pre-bundled libraries, there will be a effort in order to rebuild it for x86 and link it to the proper existing libraries. So this is where actually your effort happens. Effort comes into picture when there is already pre-bundled libraries, when there is already hard-coded instructions, that's when actually the effort for NDK happens. Otherwise, as I mentioned, all the NDK applications, the existing NDK applications seamlessly run on x86. And most of the other bugs are already fixed in the latest NDK. You can really download it from the Android developers portal in order to try for the NDK application. Okay. So this is all about how actually, this is all about the introduction for the NDK application. So let's get into the application development. Till now, I talked a lot on how, what is NDK, or what is the NDK versus the Dalvik application, what is the advantages, disadvantages. Then how actually we, I also give you the case study also for x86. But what is the actual development cycle? How does it look like? So here is the block diagram which actually speaks or pictures you the application development cycle. So you have a C and C++, C or C++ code, which is actually the native code. You want to convert those C and C++ code, or when you want to write a fresh new code of NDK, then first you write a C and C++ code, then you generate a make file for that, and then you build that one using NDK build. Then you have a Java call in order to integrate these C and C++ code onto the Android platform. Sorry, Android SDK. How do you do this one? What are these Java calls called? These are the JNI calls. That is Java Native Interface. So the JNI which I'm calling is a wrapper around your C and C++ code, where actually it allows the application and the OS to communicate. This is the wrapper which helps you, which helps for the native code and the application layer, native code and the OS layer to interact. So after that, it's the general GDB debugging, which you actually use it for any other kind of application development. So this is the development cycle for an NDK application. Let it be existing C++ code or a fresh C++ code which you are writing it for NDK development. So as I already mentioned, the block diagram here below shows you how actually the application layer and the C and the OS layer are interacting. The SDK APIs are called through JNI. So the Android application communicates to the C libraries or the C++ code through the JNI or the native libraries which you are using it. So this is about the development cycle. Let's look at from the point of view of platform. So the earlier slide which talked about the application layer, or I would mention it as application kind of a development cycle, will lead into the NDK platform. So this is the Android NDK application framework. I would not call it as a framework actually. Sorry, this is the platform actually. So as you see, the things which are in green are all the native codes. That is, let it be C, C++ source code, the header files which it is accessing, and the dynamic libraries which are present. And those which are and if you see all the layers of this Android OS are actually all interfaced through Java classes. So, for example, you have a header file which is in the native. How do you compile it into the dynamic library and link it to your link it to your Android platform? So that is through, again, you need to for example, if you see here, the header file is there. You have to link it to the actual dynamic library. You need to compile and link it to the C code. So the header file and the C and C++ source code are compiled, and they are using your make file and the application files. You will be compiling your C code, and you generate a dynamic library. So this dynamic library is linked to your the platform layer. How does that happen? That is through the Java native library class. So as I mentioned, when you in general, what happens is in Android applications, you have a C++ code, you compile it, you get the dynamic library, and then you actually compile using the Java native library class. So you get a Java bytecode. So that is Java bytecode. Again, in terms of Dalvik applications, actually you have one more layer of compilation, where actually you get the .dex code. That's actually the another layer of compilation which happens in the Android OS layer. So this is how actually an NDK platform looks like. So let's talk in detail about how actually for example, if you see here, you have how actually your offloading happens, like how actually the linking happens. There are like the further files show you in detail of the NDK development, and also linking to your Java code. So the JNI interface and the linking to your existing Java code, I'll take it further in the in further files. So these are some of the basic steps of how you actually install NDK. So you can always go to the android.developers.com, where actually you get the NDK in terms of there is an archive where actually you can download it for what kind of platform is on which you are trying to build the NDK. Let it be Windows 32, 64 or Linux, and also Mac OS. So what you need to do is you just have to download it from the Android website, and then what you need to do it is you need to integrate it to Eclipse ADT. So as shown in the picture, you have in the preferences in Eclipse, you have how actually you can link it to the Eclipse ADT. Actually, all these things in the demo it will make you more it will make it all clear. So, but these are the files where actually it will help you in following my demo session. So here actually how a JNI folder is included into an Android project. You create an Android project in Eclipse, and then you add the JNI folder to the existing project, where the JNI folder has your C and C++ code. So as I mentioned, the JNI folder is for the native sources, and then if you are reusing or creating new C++ code, you go on adding it to the JNI folder. Then you create the Android make file in order to link the Android make file actually links your JNI folder to the rest of your Android project. Then you build using the NDK build for the native libraries. Okay. So I take this one in my demo. So let's go for the demo now. Yeah. I would like to mention one more point before going to the demo. This is for configuring your NDK target ABI. What do you mean by ABI? An ABI is an application binary interface. This interface actually tells you what kind of CPUs you are targeting. So when you are mentioning app_ABI all, that means you are targeting all type of platforms, let it be x86, ARM, or MIPS, any kind of platform. So as mentioned in the as mentioned here, there are like a few platforms which for which it builds, like MIPS, x86, and then ARM. So if you want to build particular for one type of platform, then you have to specify using app_ABI telling x86 alone, or it can let it be ARM alone. So that's for which with the APK file will be generated. So these are some of the Android NDK samples which are available when you download it from the Android website. Okay. So before going to this, let me go to the demo. Okay, so this is the Eclipse ADT, the IDE tool, which is actually used for any type of Java development on your on any, or it can be Windows, or you can use it on Windows or on any other OS if you need. So this is actually a cluster of tools which you get it from the Android SDK. So when you download Android SDK, you actually automatically are installing even the Eclipse. So here I will show you today how actually the NDK applications are developed. So go to the file, go to new and create a, go to the project and click on the Android project from existing code. So this is assuming that you have already installed NDK, you have downloaded NDK from the androiddevelopers.com, and so this is, I'm going to show you how actually I'll be linking your Eclipse onto the NDK. So when you go to the existing code, so it asks you for wherever you have stored your NDK, please go to the NDK folder. So from the NDK folder, what I will do is I'll pick up one of the simple applications of Hello JNI, and I will click on finish. So I've just picked up the Hello JNI, which is a simple application written in C++ code for printing hello world. So click on finish. So by doing this, you're importing all the existing projects of NDK. Okay. Yeah. So the Hello JNI project is created. So what I do is now go to the Windows. You need to add the preferences as NDK. So this is not just an ordinary Java project which you are trying to build and run it on the emulator. This is a NDK application. So what you need to do is go to the preferences and make it as you have to specify to Eclipse telling that you have to build it as NDK application. So for that you have to give the location of wherever your NDK is stored and apply to this project. So after applying to this project, what you need to do is you have to link this one using the Android tools, telling that make it as or build it as a native code. So actually, since I've already added to the native activity, so this is actually taking it up as the native code. So what I'll do here now is, I've already got I've already linked it up now. So I will try to run it on the emulator. Let's see what happens when I try to run it on the emulator. So I'll pick up the emulator, tell it that I'll run it on the, okay, let me open my emulator. So the build is finished. So can you see the message coming up? Unfortunately, Hello JNI has stopped. So why did I get this message? This is because that by default NDK does not tell that compile it on x86 platform. It's not building directly on the x86 platform. You have to explicitly tell to the NDK, telling that, mentioning that this is the x86 platform on which I'm trying to build the NDK. So for that, what do? Go to the JNI folder. So what I need to add here is a new file called application.makefile. Finish. So what I'll add here is app_abi equal to all. I'm telling it as run it on all the applications. So as it was mentioned in the foils for you, app_abi it's all. That means it's going to run on all the platforms seamlessly. So getting back to the Eclipse. So again, go to the manifest. As I already mentioned, and NDK support for x86 started from the 2.3 versions onwards. So I need to mention a minimum SDK version. Okay. So after that, after that again I run as the target again, what I had selected. So I run it on the emulator again. Let's see how it takes up for the x86 platform. I have migrated it from the existing native development of NDK app for non-Intel platform onto Intel. So here it goes. Here it goes. This is the Hello JNI, which actually is ported from a non-Intel platform onto x86. So this is a simple step on migrating from any which is existing NDK application onto x86. So let's get back to our poise. Okay. Yeah. So we saw how actually we used the NDK sample application which was available, that's the Hello JNI, in order to port it onto x86. So let's now get in little more in one step ahead of how actually how did we integrate this C++ code with Java. So there are two methods of integrating this Java, the native functions with Java. The two methods are the Java method, that is Java header method, and the JNI onload method. So what happens in the Java method? So what in Java method, what actually you are doing is you are just producing the C header files and C source files from the Java class. So this is, for example, let me go a little in depth about the Java description. So this is actually a method which is going to automatically generate the appropriate JNI folder or the JNI header stub for the existing C++ code in order to link to your Java functions. So if you see in the example, so this is the syntax of Java, where actually you're telling create a JNI class path for this particular class, that is com.example.hellojni. This is the Java class for which you are linking using the JNI. So what it generates? So it generates the hellojni.h, that is the header file, with the destination of exporting the JNI calls to exporting the JNI calls to the actual Java class. So this is the Java method actually used. See, for the next call actually gives you in more detail where actually your Java method is called. The hellojni.java, which is there in the source folder, actually gives you the liberty of loading the library for loading the string from the JNI. So the public native, the native keyword actually tells you that this is a porting of C++ code onto your for your Java class. So this is the keyword which we use it for the NDK development. So yeah, how is the C function automatically mapped? So C function is not actually automatically mapped. What we use is the J string in order to the J string which is used in the C file actually what do you call, the imports the native code, the native call from the hellojni.java. So this is the Java method which is used. So what is the another method called? That is the JNI onload method. So why should we go for a JNI onload method? This is the actual JNI onload method is actually provided from the from the Android open source project. So it's actually a proven method. So you are safe there. When you're using JNI onload, you are not exposed to any surprises that okay some Java class crashed there or it did not register the methods. So all these kind of problems are not going to come up on JNI onload. So most of them prefer JNI onload method for linking your native code to the Java class. So and adding and removing native functions is also easy here. And also there is a best spot for caching your Java class object. So this is also one of the added advantages on JNI onload method. So how does the JNI onload method look? So if you see here, again, it's going to be again a J string from the JNI, which you actually will be invoking from your Java class. So this Java class is in your source folder, where actually I showed you the .java file. So what you are doing here is you are going to string from JNI, and you give the JNI environment, that is the objects available for the JNI onload. And when you come to the JNI onload method, actual onload method, what you do here is you give a entry point to the for loading your Java classes. So this actually you can, the samples will give you more insight on JNI onload method, where actually you get to see how JNI onload is called from the C++ libraries to the Java class. Okay. So the demo was done for the migration. So I would like to give one more demo before getting on to the optimization method, where actually it will give you insight on Dalvik versus NDK applications. So here I've linked to one of the x86 platform. So if you can see the screen here, this is linked to one of the x86 phones. So here I have the code for both Dalvik and the JNI and NDK. So what I'll do here is I'll run a small application which is called the Fibonacci application. So this Fibonacci application is a mathematical intensive function where actually you are using recursive calls. So this recursive calls, let's see how actually is implemented both in Dalvik and native. So which gives the better performance. So let's give a random input and see the result of Dalvik and native. So if you can see here, in the Dalvik recursive function, you got around 2100 milliseconds, and in native recursive you got around 195 milliseconds. It's almost more than 10x performance improvement which you get from the native recursive. So this is the performance in Dalvik and native. So this gives you an insight what kind of application you want to develop. A simple mathematical application can give you a 10x of performance improvement. Then imagine the complex algorithms like encoding, decoding, and gaming. How much performance improvement can be utilized in NDK? So after the demo, let's get into some of the optimization steps which are available for NDK applications on x86. Okay. In optimization, I would like to mention two types of optimizations which are available for x86 platform. So one of them is the vectorization. So in the earlier calls already I had mentioned on SSE3. So the instructions which are available on for x86 gives you a lot of performance improvement in terms of the mathematical operations. Like for example, you have as I mentioned in the Fibonacci series, you have a recursive functions happening where actually you have cumulative additions, cumulative multiplications happening. So these kind of mathematical functions can be very well optimized using vectorization. So the SSE 4.2 is available for the Intel Silvermont microarchitecture, where actually you can perform an operation of 16 bytes at a time. So this is the kind of optimization level which you can achieve using SSE 4.2. So there are also other vectorizations in non-Intel platforms, like in ARM you have the ARM Neon instructions. So as I mentioned, there are like two types of instruction sets in vectorization. One is the compiler auto vectorization, and the other is the compiler intrinsic. So in the compiler auto vectorization, what happens is you are mentioning it, telling that use SSE 4.2. So this is how I would tell you're forcing your compiler to use some of the optimization steps for that particular platform, like SoC 4.2 for the Bay-Trail platform from Intel. And the other is the compiler intrinsics. So when you use like Intel C++ compiler is there. So these are the compiler intrinsics which are integrated into the compiler itself. So you don't have to really go and mention telling that use this SSE 4.2 for this kind of vectorization. So the intrinsics automatically come up on that particular platform, and they optimize for you in order to achieve this vectorization. And the next is the GCC flags. So there are a lot of GCC flags which are available for optimization. In order to achieve, for example, in mathematical performance, you can go for FF fast math flag. This FF fast math flag actually gives you kind of as I already mentioned, the kind of optimization for the floating point operations in mathematics. So these kind of optimizations can be achieved using FF fast math, and the MTune flag actually gives you the CPU specific instructions for optimization. For example, when you mention mtune equal to atom, so this is going to optimize your C++ code for atom platform. So, and you give mtune equal to SLM, that is for silver mount. So this is going to again optimize for that particular platform. So when I tell optimize it for that particular platform, so SSE 4.2 is available for silver mount dimension. So it's going to start using 16-byte operations instead of the previous one, which was for SSE 3. So this is the advantage of mtune flag. So yeah, so we came up with lot of demos and lot of demos which showed the performance of Dalvik and NDK also. So let's summarize all these things. Like, what did we achieve when you developed an NDK application? So the main intention of NDK application development was performance for critical applications. Critical applications like complex algorithms, mathematical intensive functions, all these things go for NDK. That's the best use case model for achieving your performance. And it's also easy to target multiple architectures. So when, as I mentioned already, NDK is already there in multiple architectures like ARM, Neon, MIPS. So the only thing which you have to take care of is your APK file, which actually platform you are targeting. Just mention it in your app ABI interface, which will give you that particular APK file. So you are targeting multiple architectures here. And for each architecture, as I mentioned, you're having your own type of optimization steps. So go for it and target multiple architectures. And there are a lot of tool chains which are available for NDK applications, development, deployment, and also optimization. So let it be from Intel and also from the third-party vendors. There are a lot of applications on NDK development. So on a summary, we have a critical application which for performance. Go for NDK. So this is all about the NDK application development on x86. So please, I'm opening up for questions now. Thank you.
Thank you so much, Nalina, for that presentation. I'm going to assign the questions to Suprabha now. Or do you want me to assign the questions to both of you?
Yeah, both of us is fine.
Okay. So I'm sending the questions in the chat window so that both of you can view it. Give me just a second.
Mm-hmm. Okay, we have a question from Amish Shukla asking, when we compile for all platforms, does it increase the size of compiled app? Yes, it increases the APK file, that is the compiled app. After you build any Android applications, you get a APK file. So when you're building for all the platforms, the APK file will be huge. So that's why we have the options of in the ABI telling which platform you're targeting. So having multiple APKs is always better than having a single APK file which is very huge. So this will create a fat binary, and people, I would tell, hesitate to download it from any kind of stores which is the APK file is huge. Okay, one more question. Is it possible to use existing JNI libraries while writing new NDK applications? JNI libraries? Yes, it's always possible for you to use the existing JNI libraries. That's where actually when I was doing the demo, I actually took the existing JNI libraries only to in order to port it onto NDK. So that's always possible by adding the native support to the existing application. One more question. Could you please explain in brief the screen previous to configuring target NDK APIs? Okay. Yeah. So this is the screen previous to the configuring NDK target app. So this is how actually we add the NDK support to the Eclipse Android IDE tool. So what you need to do is you create a project using that as I showed in Eclipse, you create a project for an existing code or a new project. After creating that project, what you need to do is right click on your project and go to Android tools, and there you click on add native support. So by doing this, what you're telling is you're telling your JNI calls to link to the Java code which is present in the source folder. So this is how actually you are going to add the native support to your NDK application.
Question from Arun Kumar. Okay. Is there any special permission needed to add in manifest file?
There is no special permission needed. As I mentioned, for x86, you need to mention the minimum version. So as I mentioned, the NDK support for x86 started from 2.3, that is from the Gingerbread onwards. So the target, the target version should be more than greater than 10. So that's the only thing which you have to consider while porting onto x86.
So the next question is from Nagendra Sharma. How can I link existing static C libraries to JNI code to use them?
So the to JNI code to use them. Okay. So whatever the native code which you are having should be available in the JNI folder. So that's after adding the JNI, putting all these things into JNI folder, let it be the existing source code, existing libraries, everything should be in the JNI folder. So this JNI folder, you have to put it into the Java project which is there, which you have created using the Eclipse. So after that, you add the native support to this complete project.
Next question is from Yashraj. Apart from gaming and mathematical operations, can we use NDK for optimizing GPS apps?
So when you are talking about GPS apps, so as I mentioned already, NDK is for performance. So if you're looking at, like for example, in GPS you have some like longitude, latitude calculations and all. So I would assume again you are having kind of a little computation happening there. So some of your modules you can always push it onto native code and integrate it into your existing application. So there is always a good chance of performance improvement. So I would recommend to try for that one.
Next question is from Badrinath. Android also has render script which provides high computation and is platform independent. Any thought on when to use render script and NDK? Yeah, Badrinath, actually we have not really explored render script to a large extent. We will, what we can do is we can really go through it, check what it provides, and then do a comparison of render script and NDK and then come back to you. Sorry, we don't have an answer right away for this. Next question is from Balaji. If we have function add in native code, which will be the function call in Java app code?
Which will be the function call from Java app code?
I think the question is what will be the corresponding function in the Java application code.
So, Balaji, what you do is you have all the C++ code as I mentioned in the JNI folder. So what you have to do is either using the Java method or the JNI onload method, you need to link these code to your Java class. So as I mentioned in one of the in this foil only itself, you have how you actually integrate your native functions with Java. So what you need to do is you need to add this kind of declaration where actually you are telling public native string from JNI. So this is how actually you are linking your for example any simple application which was hello world. So your add function has to be in any C or C++ code, and in the make file, that android.make or the android.make file, you need to add this public native string to call the your add function from the JNI.
Next question is from Arun Kumar. Next question is from Amit Shukla. So we cannot use JNI support for x86 for Android 2.3.3.
Above 2.3 you can use it. So 3.3 it will support.
It is possible, yes. Next question is from Arun Kumar. What is difference between Android Make and app.make?
Okay. So in Android Make, you are actually just mentioning that you're giving a make file for, or you can tell for the C++ files, you are giving a make file using android.make. So in the application.make, you are actually targeting the CPUs, which kind of CPU you need to build for, or which kind of APK you need to generate. So the application.make file gives you the CPU specific APK file.
Next question is from Yashraj. How to tell ADT that current project is NDK?
This current project is NDK project. Okay. So in the demo I showed, just create a project initially. After creating a project, you go to click on the project and add the preferences. In the preferences you have like, okay, let me go to the Eclipse thing. I'm assuming that you're able to see this Eclipse thing.
Yeah, we are able to.
Okay. So when you're clicking on the project, so go to the preferences, and in the Android you are telling that telling that this project is NDK. So you're adding the preference telling that this is NDK. This is how you actually tell that the current project is NDK project. And after that you again add the native support, add native support. So these two things tell that this is NDK project. And finally, to look at your NDK project, a .so file will be created. So any project which is having a .so file, this tells that this is the NDK project.
Next question is from Sajid. Can we write code for Bluetooth communication in NDK?
Sajid, I have not actually played around writing applications on NDK, like different categories.
Let me make an attempt to answer this.
Yeah, sure.
So there are already Bluetooth API that are exposed by Android for Dalvik application in itself.
Yeah.
So I don't see a special need for writing NDK application if it is plain Bluetooth communication. But if there are certain things which are not supported in Dalvik, you want to do something at the RFCOM layer of Bluetooth, for example, then maybe there are certain NDK APIs. I'm not really very sure about the different APIs or NDK level APIs that are available for Bluetooth in Android. But my guess is whatever you would want to do in Bluetooth, you should be able to do using Dalvik.
Okay.
Next question is from Kaustubh. Does this performance improvement, or I think, is this performance improvement same across ARM, MIPS, x86?
In performance improvement,
so I think the question, the way I interpret this question is, so do we get the same kind of performance improvement for ARM, x86 and MIPS instruction or MIPS architecture if we go about developing NDK apps.
Yeah.
So the NDK is very tightly coupled with the underlying hardware and hardware architecture. So the kind of performance improvement that you will see with an NDK app is also dependent on the hardware platform. So I don't think you will see similar results just by writing an NDK app on different platforms. It really depends on what kind of an SoC is there down beneath actually handling the instructions from the NDK layer of Android. Next question is from Badrinath. We have native activity in Android 2. Would be easy to use that one. So we have native activity in Android 2. Would it be easy to use that one directly instead of writing an NDK application?
So if your application is that simple, just go for native activity. Don't jumble around writing a new one. Add it onto your native, the existing native activity itself.
Next question is from Sunil. Are you saying building applications in NDK more than Dalvik SDK for best performance? Yes. If you really want to use the underlying capabilities or the capabilities of the underlying hardware to a maximum extent, you can use NDK. So whenever we talk about Dalvik and Dalvik apps and the Java API provided by Android, there is an additional layer, the Java virtual machine or the Dalvik virtual machine layer that comes into picture at runtime. That is not there when you are using the NDK API. So you are directly talking, or the translation there is no translation that really happens at runtime. The bytecode that is generated from your application directly runs on the underlying processor. Am I right, Nalina? Do you want to add something?
No, that's
so if you really want better performing applications,
for NDK,
which is really compute intensive. So if your application is really waiting for user inputs and stuff like that, I don't think they are real candidates for NDK applications. But if they are applications which are compute intensive, typical examples like Ladila has already mentioned, games, mathematical mathematical algorithmic oriented applications, these are certain examples of
NDK
candidates for NDK applications.
Yeah.
Next question from Sunil. Where can we get detailed documentation about NDK?
I've just given you the useful resources slide. You can go to software.intel.com and /NDK for IA, or in general NDK, just go to developers.android.com.
Okay, next question is from Shreyas. The x86 and non-Intel comparison demo was a single APK. How was the output calculation done for two different platforms?
What is the output calculation? I didn't get exactly.
Yeah, I think Shreyas, if you can really elaborate a little bit more on your question, that will be good, because neither am I able to interpret the question correctly. We will move on. Next question is from Siddharth. There are few docs on Google Docs which say that we should use NDK only when it is the last option and use the Java for all purposes, even for gaming apps. Okay, this I would say is more of
ease of application development. That's it. So
I would even say that, yeah, from Google's standpoint or from Google's recommendation standpoint, yes, it makes sense to be using Dalvik because of its portability across platforms. That way, it doesn't really tie you down to a particular platform. But like I mentioned earlier, what happens is there is definitely an additional layer that is coming into picture at runtime. So we have even calibrated certain gaming applications which are done only using Dalvik, and as soon as we optimize the same applications using NDK API, we have seen a significant difference in the performance, a visible and a significant difference in the performance of the applications. You may really want to try it out, and we can even give you data on what is the performance improvement that you will see when you move to NDK applications.
Next one is from Akshay. Can you chart out the basic steps in porting an app based on platform specific library, for example, Qualcomm FastCV to x86. So if you're just porting an existing application and it is not having any hard coding or kind of platform specific libraries, as I already mentioned, it seamlessly runs on x86 and there is no need of extra effort. So if there is any hard coded instructions, then you have to write a scripting, do scripting in order to convert those hard coded instructions onto x86 compatibility, and tightly coupled native libraries for a non-Intel platform. Then you have to recompile it for x86 libraries.
Okay, next question is from Arun Kumar. In my app, I'm using third-party library to use, I think it's to scan a picture in ARM6 devices. I have to disable the scan function using single APK. Is it possible using NDK to achieve this? I have to disable the scan function using
single APK.
Okay, I think he has to scan a picture and after that disable the scan functionality altogether. Is it possible using NDK to achieve this? I am not very sure about whether this particular scanning functionality can be enabled, disabled using NDK. I'm not sure, not explored that particular area. Let's move on. Question from Santosh. Can you debug and show the sample Hello JNI example which you have in Eclipse?
Okay.
Is it any, Nalina, is it any different from debugging a normal Hello World application?
No, it's very much similar. Just go to the debug mode and you have to step in, step out. So it's a Eclipse IDE you are using it. So
you want to do a breakpoint and then just show that?
Okay. So let me tell that debug as Android native application. Okay, it's if you can see here, it's because of the ABI. I think I have given it as all. It's not taking up all the. It's telling it unable to detect all the application ABIs. So it's not going to the debugging mode. But I would tell if you have used Eclipse and you have used any Java project, it's very similar to that. Add the breakpoints and go to the debug mode, and you can step in, step out, and use it as the normal IDE function, IDE tool.
Okay, next question is from Ranganathan. I understand there are tools which convert J to ME midlets, .jad, jar to Android apps, APK. Is it true? If so, are they effective 100%? I'm not sure. I have not used a J to ME to Android converter ever. So,
Ravi, can we update UI from NDK lib? So if I'm assuming that updating UI in the sense you are telling that controls, giving controls to UI. So it's like if you are in Dalvik, you're already having some APIs which expose for that one. So what if you're as we mentioned, go for NDK when you're having applications which really need performance. So if you think that the UI calls and there are lags in that one. Like as I mentioned that there are the lags and the animations, NDK plays an important role. So if that is the case, you can always go for NDK, and you can link to the to your project.
Yeah, I think we have 3 more questions and we can wind up after that. Next question is from AVM. Performance is not my criteria, but I want to use NDK because it provides me an option to invoke low-level interfaces, which is not possible through standard Java apps. Will this be a good approach to test something at the driver level? Any suggestions? So if the low-level APIs are not really exposed to Java, I don't think you have an option but to use the NDK API to do all the low-level driver level stuff that you are talking about. So go for it.
Go ahead and you can use it.
Next question is from Nagendra. System load library will load the library. What is the command to close or remove the library from memory? How is it handled by the application manager?
So if we are telling there is a, so you can go for the, when this is the memory management thing which you are talking. So you are
talking about the library loading and unloading.
Oh, okay. System load library will load the library. What is the command to close and remove the
library from memory? I think this is
handled by the
handled by the application manager. As soon as your library kind of goes out of context and it is no longer used, this is a .so. It is equivalent of a DLL if you are very familiar with the Windows Windows terminology. So as soon as the system or Android figures out that the .so is no longer needed and all the applications that are using a particular shaped object have kind of closed, the system takes care of unloading it from memory so that you have memory available for other running applications. Next question from Arun Kumar. Is it possible to access mobile hardware controls using NDK code? For example, I want to mute Android mobile using NDK. Is it possible?
So it's again as very similar to the previous one, giving controls to the drivers level. So if you want to like play around with the lower layers of the application framework, you can go ahead and use it. So there is no problem in that one.
Last question from Yashraj. Which other technologies as a pure Java developer must learn to use NDK in Android application?
As a pure Java developer, if you're already a Java developer, then you don't have to really learn anything for NDK development application. It's a simple C++ code which you actually write it in, and integrate it to your existing Java project. So if you're already a Java expert, C++ is nothing for you to come up with.
Okay, so Sri Lagna, I think we are also running out of time.
Yes.
So how do we go about it? Do we have more time or should we wind it up here?
Well, I'm getting in a lot of questions, but looking at the time, perhaps we could request the attendees to take up the questions with either Nalina or you offline, if that is okay. If you want, you can also go ahead and share your official email IDs, or else they can share the questions with us at the end of today's session, and we'll be more than happy to share the same with you.
Sure. Just I'm on the slide itself, I'm just writing the email ID for mine and Suprabha. Please feel to come up with questions which we could not answer it right now.
Yeah, sure, absolutely. We will be more than happy to answer all your questions that we receive over email. Please drop us emails with your questions and we will be happy to get back to you with answers.
All right, thank you so much, Nalina, and thank you so much, Suprabha, for giving the wonderful presentation, and I'm sure it was really helpful for all our attendees today. And once again, here are the email IDs for Nalina and Suprabha: nalina.jain@intel.com, and for Suprabha it will be Suprabha, suprabha.mysore@intel.com. Request you all to share the questions with our experts, either that or you can send the questions directly to Techgig. Thank you once again for all your support and making this a success today. The recorded webinar will be available on techgig.com by tomorrow afternoon. So those who would want to come log in again and go through the presentation, feel free to log in on techgig.com by tomorrow afternoon. Thank you so much once again, ladies and gentlemen. I will quickly end the session now. Thank you once again, Nalina and Suprabha, for the presentation today.
Thank you.